All right, let's go ahead and take a look at your homework. Page 253, you had numbers 5, 8, and 11. We were graphing two variable inequalities. Obviously, one variable, you just have a number line, right? It's either a dot or a circle, and you shade one side or the other, right? But with a two variable inequality, we have to graph on the Cartesian plane. In some cases, if it's a linear inequality class, we will graph a line. But the line may be a solid line or it may be a dashed line, right? Or dotted line, right? If it's a quadratic equation, very likely, at least the ones that we were doing, would probably be graphed as a quadratic equation, be graphed as a parabola. Very good. Parabola. Hand motions do help. It's true. Now, granted, there are other quadratics, right? We saw some examples of those different graphs, but for our purposes for now, we're just dealing with the parabolas because we know how to graph them easier. But again, the parabola may be a solid curve, or Brandon, it may be a dashed or dotted curve. But the dashed or dotted isn't the only thing different that we did yesterday, and as we were working on the homework, page 253, numbers 5, 8, and 11, we also had to do what else in addition to possibly drawing our line or curve as solid or dashed? Maddie? Had to color, right? We got to color yesterday. Shade is the word I would use. You have to shade part of the Cartesian plane, whichever part satisfied the inequality. So as we look at number 5 from the homework, we were given the inequality 8x positive 4y is greater than or equal to negative 24. If this said equals, I'd have a linear equation. And to graph the linear equation, what would I likely do, Kendall?
You could reduce it by taking a 4 out of it.
I knock a 4 out of everything right up front.
To get 2x plus y is greater than or equal to negative 6.
Good. I could do it in an equation. I can do it in an inequality. Not a problem at all. Then what would I do?
You send the 2x over as a negative.
All right, to get
Y is greater than or equal to negative 2x negative 6.
And by doing so, we've essentially got this class in slope-intercept form, right? Where we've got our y-intercept. I'm just going to do a quick sketch for now. Our y-intercept is negative 6. And so as you check your graph, hopefully, down at negative 6, you had a dot. And then from there, class, we're going to rise 2, go backward 1. So rise 2, go backward 1. And again, when we connect the dots, we now have to consider solid or dashed line. Which one is it, Abby?
Solid.
It is a solid line. So checking your paper, did you have a solid line? Again, got to go pretty much to the top and bottom or side to side of the graph. Do we have this line, first of all? But it's not just enough to have the line. We then have to shade either everything on this side or everything on that side of the boundary. That's essentially what this does. Forms a boundary of all the points that do work with all the points that don't. Just as the solid dot or open circle on the number line served as a boundary between the points that satisfied and did not. How do I determine which side of the line we're going to shade in, Genesis? Not necessarily.
Put zeros.
Pick a not so random test point, right? And specifically the test point you wanted to use was 0, 0, the origin. Unless the line or parabola or whatever figure, those are the two we're doing, happens to go through the origin, you could use this point as a test. So we plug it in. X is 0, Y is 0. And we plug it in. This statement now says what, Genesis?
0 is greater than or equal to negative 24.
Good. 0 is greater than or equal to negative 24. Well, if that's true, then this point is part of the solution, which, since it's on this side of the boundary, that would indicate all these points are part of the solution. If this is a lie, then it doesn't satisfy, which means nothing over here will. We have to shade the other side. Is this true, Audrey? Yeah. So we're going to go ahead and shade this side of the Cartesian plane, and it's moments like this that you wish you'd drawn your graph a little smaller because it makes it easier to shade. And again, this is acceptable for shading. It shows me what you're shading. Just don't cross over your boundary line. If you want to do really detailed shading, as I see some of you did, I've also seen some of you art people, scribble a lot and then take your fingers and rub it all in and stuff and make it beautiful. If you want to do that, I am not. Did you do that? All right. I'm not going to gripe about it. More power to you. I'm too lazy, but this is your chance to color and connect the dots and stuff. So I'm not gonna rain on your parade. How many essentially had this for your graph on number 5? Number 5. Okay, just a couple of you questions from those who did not. All right, we understand it now. If we missed it.
I just lost my negative, so I went the other way.
Oh, I gotcha. Okay.
I put my greater than less than a symbol when I plug in the 0. So it says 0 was
less than, and so you shaded the other side. Okay, let's take a look at the next one, which was number 8. And this one is quadratic. How do I know just as soon as I see it? Oh, it's quadratic. Brandon?
the square.
The square. As soon as I see the square, I know it's quadratic. Now, they were nice enough to put this in the parabolic form. So I know I'm going to get a parabola, but two things need to change from my base parabola. Remember vertex 0, 0, over 1 up, 1 over 1 up, 3 over 1 up, 5. I'm going to make two changes to that. What are those two changes, Michael?
You are going to go down 1 and left 2.
Good. I'm going to shift it down 1 and backward 2. And I am going to go ahead and use the graph grid here because I'm not too good at freehanding points here. Since I'm going down into the third quadrant, down and back, I'm going to give myself a little bit more room for my third quadrant here, perhaps. Nothing says that it has to be balanced and equitable here. So I'm not going to, I did think I told you you didn't actually have to put increments. I don't know why I'm doing it. So down 1 and backward 2. It's going to put us right here. And that's where our vertex should have been. And then from there, class, we will go over 1 up 1. And can't quite fit it, okay? When I draw my parabola, will I use a solid curve or a dashed curve, class?
Solid.
A solid curve. So something like that. And again, we need to pick a test point. It didn't go through 0, 0, so I could use 0, 0 as Genesis said. That means a 0 goes in for x and 0 goes in for y. That gives me what statement now? Maddie? Well, careful. What is 0 plus 2? Squared minus 1. 3. So we've got to be careful with our math here. It ends up giving us 0 is bigger than 3. Is that true? No. Well, notice where the point falls. It's not about whether it's on one side of the line or the other. It's whether it's inside the parabola or outside. Well, class, clearly it is outside. So I'm going to shade inside because it didn't work outside. So again, making sure we go to the top of the graph and we'll shade everything inside the parabola. How many had this for number 8? It's several of you. Questions on number 8. Questions on 8. All right, let's take a look at the last one that you had, and that was number 11. And for number 11, we had a y is less than negative x squared positive 1. All right, again, it's your base parabola, but with two changes. What are my two changes this time? Kendall?
You're gonna shift to the right one.
Is this grouped with the x squared?
No.
When it's grouped and squared, we shift left and right. In this case, it's after, so it just goes up 1. And what's the other change?
You're going to flip it.
We are going to flip because of the leading negative right here. So in fact, let me go pink on this one here rather than drawing a new Cartesian plane. I'm going to shift up 1, and that's the only shift, but then it's going to be over 1, down 1, over 1, down 3, and do I have room to go down 5? I do. So I'll go ahead and put those points there since I have to go to the end anyway. So something like, oh, wait a second. Solid curve or dashed curve, class?
Yeah.
As I'm drawing, I'm like, oh yeah, I got to make sure I'm doing it correctly, and I am not doing it correctly, so I'll just make some little sloppy edits here. It's not how you start, but how you finish, right? All right, so there's our dashed parabola there. Now, notice 0, 0 is just in, okay, I'll draw a little bit fatter. That was really bothering you, okay? The 0, 0 is just inside the parabola, correct? Just barely in there. Let's plug in the 0, 0. What does my statement say if I plug in 0, 0? Audrey?
0 is less than 1.
Good. Is that true?
No. Yes.
Is 0 less than 1? Yes, it is. Okay. So since 0 is less than 1, the origin is true. So if it's true and it happens to be inside, then class, I'm going to shade inside. And this time it happens that both are inside, which I definitely like best when it's inside because it means less shading for me. I don't like shading the outside. Unfortunately, I didn't have to on either problem. How many remembered the dashed parabola going downward up 1, and then a shading inside? You had this for number 11. Okay, just a few of you questions from those who did not. Do we remember this now that we went over it from yesterday? Let me give you a few more. We're going to have some graph paper out. You don't need your books for now. Let me give you 4 more inequalities to graph. So set up 4 little graph grids, or be ready to set up 4 little graph grids, I should say. That should fit on one side of a sheet of graph paper. So should be good with just that much. Start with 2x minus 5y is less than or equal to 10. Y is less than x negative 3 squared negative 2. 3x positive 2y is greater than 4. And y is greater than or equal to negative x plus 4 squared. 4 inequalities for each graph. those where you, if you had a crayon, you turn it sideways, right, and rub it all.
I mean, chalk does work like that.
Yeah, but I hate when it reshapes the chalk. So, and it does. It rubs a flat side on round chalk, and yeah. But you could do that with chalk as well. It's true. Instead of princesses and puppy dogs, it's parabolas and straight lines. How times change. Mitch is just like, I still make crowns on mine and color those in. Again, the smaller you draw your Cartesian plane, the less you have to color. So don't make them too big. A fourth of a page is a good size. Y'all do, in the art class, did y'all do pencil drawings yet? Talk about the different kinds of art pencils, the H, the 2H, the HB, the B, and the 2B. Different hardnesses of a softer lead may be really convenient for something like this, like a 2B pencil. Of course, as you finish them, check. If you have questions, ask. I got lucky on the homework and unlucky on the classwork.
So I have a question.
Yes.
The last one, would you count that negative on the outside then?
Right, the negative is on the outside of the parentheses here. So the 0 plus 4 is 4, squared is 16, but it's negative whatever you get after you square. It's not a negative 4 that's being squared, it's negative 4 squared. Yeah. Which unfortunately means it's true, and unfortunately means sad life, sad life. Kendall perfect on all 4? Abby perfect on all 4? Genesis? Good. Brandon? Yeah. No? Which one?
The last one.
What did you do?
I moved right 4 instead of left.
Gotcha, so just wrong direction.
Mm-hmm.
Still have the outside shaded, is that right? Okay. We got a couple of art students who are still completing their masterpieces, so we'll give them just another moment or so.
Just take the lead out, Mike.
Just rub it when you're done.
Get your finger kind of messy.
But then you could use your finger to shade the next one in.
Life hacks.
5-minute craft.
Craft time with Michael.
I agree on you.
Welcome to my TED Talk.
Alright, Maddie, good to go? And uh-oh.
I'm just
But yeah, but we still have an uh-oh.
Uh-oh.
You went up 4
shaking.
instead of left 4 still shades. Alright, other than that, so in that case though, Audrey, you should have stayed to the inside, shouldn't you? Because 0, 0 worked.
Yeah.
So we had 2 uh-ohs on the same, and that's a big, mega uh-oh.
Yeah.
Questions on this?
The second uh-oh kind of fixed.
No, it didn't. Questions on the questions on these groups. Was that the only one you had a mistake on?
Yeah.
The others were good? Are you sure?
Yes.
All right. Go ahead and next thing in your notes, let's build on this idea of how to graph a 2-variable inequality. Next thing in your notes, systems of inequalities. Systems of inequalities. Obviously, we know a system involves 2 equations normally. And so what we would do in a system of equations class is we would graph, if we had to, the 2 equations, right? And where the equations intersect, you would have your solution, correct? But in inequality, it's not about the line itself. It's about a whole section of the Cartesian plane. So picture this now. We've got, for instance, a linear inequality in which maybe we shade everything up here. And then maybe we have a quadratic where maybe we would shade everything outside the parabola, correct? What we're going to look for is where do the shadings intersect, or rather where do the shaded regions overlap? Well, right here and around here is where they overlap. So here you go, Abby, this is for you. Your actual solution is this region because it satisfies both inequalities. There's a little piece in here that satisfies the first but not the second. There's a region out here that satisfies the second but not the first. Where do the shaded regions overlap each other? Does that make sense? So this is a situation where colors of ink could come in handy, or colored pencils could come in handy. Look, if you would, actually write this, jot that down if you would, where regions overlap. Systems of inequalities. The solution is where shaded regions overlap. The solution is where shaded regions overlap. Once you have that written down in your notes, look at page 254. We're going to look at several examples first. Now, of course, they use computer-generated graphics. So I know they have a little bit of an edge here. Page 254. We see the first inequality is marked by that solid line, and it's everything above left of the solid line, and that's been shaded in. The next inequality is everything below and left of the dotted line. Do we see it? Page 254. But notice there is a V-shaped region, sideways V-shaped region, that is both below left the dashed line and above left the solid line. That region has been double shaded. It's been shaded by both inequalities. That's the region of points, the collection of points that satisfy both inequalities. Does that make sense? All right, look at the next page, across the page rather. Here we have three inequalities. We have the diagonal line, first of all, and everything below the diagonal line. Now notice, they didn't actually shade everything below the diagonal. They stopped because they saw what was coming next. Then they shade everything to the right side of the x -2 line, right? So there's this vertical line. Everything to the right-hand side is bigger than -2 for its x. All right, so that section's been shaded. Then they also have everything above the horizontal line at -3. Now, they didn't shade everything because they knew once they got to that slanty line, they were going to, it wasn't going to work anyway. And notice there's a little triangle right in the middle of all of it that satisfies everything to the right of the one, everything above the other, and everything below the slanty. Do we see that? Three inequalities, and they form a little triangular section. They went ahead and identified the vertices of the triangle as well. Easy enough to do from the graph. Questions on example 5.6b. Make sure you're focused on your work there, Maury. On example 5.6c, they had two lines. First of all, they had everything shaded above left of the solid line. Then they shaded everything below right of the dashed line. And since those lines were parallel, the regions never intersect at all, do they? There's no solution. No point, not a single point on the Cartesian plane can satisfy both inequalities simultaneously. Make sense? Look at the next page. Here we have a quadratic, first of all, where they shade everything inside the parabola. They have another where they shade everything below right of a slashy line, of a slanted line. But notice there's just this tiny little region in there that is both in the parabola and below right the slanted line. So a little tiny, funny shaped, not even sure what you'd call that. If it had a little thing in it, you'd call it like a Nike swoosh, but it doesn't have a little, so it's not a Nike swoosh, it's just a thing. Questions on how they arrived at the thing as the solution there. Notice in each case they also identify the vertices of the region. So the vertices that identified there is 2, 0, -1, -3. Of course, we can see that from the graph. Questions? All right, so if you have highlighters, colored pencils, colored pens, stuff like that, now's the time to break them out. Let's do some of these together. Go ahead and set up a Cartesian plane on your paper, and we're going to do number 1 together. We'll start with 2 linear, because frankly that's easiest. So we'll do a pair of linear inequalities to start. We're going to be smart, like the textbook. We're not going to shade everything the second time. The first time we shade everything. The second time, we should already know what we're shading and how we can only shade what's absolutely necessary. So my first inequality that they give us is x plus y is less than 12. Oh man, 12. Lovely. Okay, so when we put it in slope-intercept form, yes, ma'am.
Is this a big Cartesian line?
Well, I just discovered it's going to have to be. Let's wait on the Cartesian plane for a minute, because I'm going to need to make a little edit here anyway. First of all, to get into slope-intercept form, class, move the x over as negative to get y is less than negative x plus 12. What's the y-intercept? All right, so I do not want my x-axis here. I want my x-axis down here. And hopefully that doesn't mess up the next one. But hey, I'm going to live in the moment. Right now, I need a 12. There's 3, there's 6, there's 9, and it still just barely fit. All right, so 12. From here, class, we would normally rise 1, run, backward 1. But I'm going to put it in reverse. Instead of rise, go backward, I'm going to fall and go forward. Still gives me the same negative slope. And solid line or dashed line, class? Dashed. I really hope I get to shade the top part. That would be really nice. It's a small little piece up at the top. All right, so how do we know if we get to shade the top or bottom? Well, we plug in a test point, class. 0, 0, which is way down here. I would love it if it didn't work. You plug in you plug in 0, 0, and does it work, class?
Yes.
It does. Okay. I'm going to do a very loose shading like this. Because again, all that really matters is my final solution. But the point is, all of that is going to work eventually, okay? But I'm not doing the detailed shading. Number 1, I'm going to run out of chalk if I do that. Number 2, that's just annoying. All right, let's go to our second equation in the system. So there's equation number 1. Equation, or inequality number 2, rather, is x minus y is less than 8. Well, let's get this into the slope-intercept form. Genesis? As a, to get negative y is less than negative x plus 8, but I don't really like the negative here on the y, so class, let's switch all the signs. But when you do, what happens to inequality? It switches also. So what do I end up with, class?
Y is greater than x plus 8.
You've got to be kidding me. They hate us. Okay. I mean, I just barely fit my 12 as is. So my y-intercept, class, is negative 8. So we're going to go down. Let's see, this is 3, 5, 6, 7, 8. And from there, our slope, class, is 1 over 1. So we're going to rise 1, run 1. And a solid or dashed line. Dashed line. And we're going to get something like that. And we again pick a test point. 0, 0. And I plug in the 0, 0, and does it work, class?
Yes.
Now, what that means is normally I would be shading in everything up here, correct? But I know I can't go on this side of the line anyway. So really, it's everything within this right angle here. And so there's my solutions, and they better not do that to us on the next one. I'm not sure what I do if they do it, but they better not. I hope they don't do it to us on the next one. That's annoying. Note to self, don't do that next year. Do it to them. You're like, we had to suffer, they should suffer.
Yes.
I like your vindictive, spiteful spirit, Genesis. It's inspiring. All right, we'll leave it in the lesson plan for next year. Number 3. That's probably what last year's class said too. Let's take a look at number 3. Hopefully this works out better. Surely it does. We got a negative x plus 2y is greater than or equal to 14.
14.
It's okay, there's a 2y. We're going to be all right. 7. That's not as bad, okay? It's not as bad. All right, what about the next one? 5x positive 2y is greater than or equal to negative 10. It's still not too bad, okay? All right, so we can already see the 7 and the negative 5, right? All right, so make sure you've got those on your Cartesian plane somewhere, huh? Pink chalk doesn't erase as well. Not that I am complaining actually. Bought that pink chalk. I should be using green. Well, no, green wouldn't show up on the green chalk, but I was about to say, Valentine's Day is old news anyway. That's the only reason the pink was down here. Should get the green chalk for St. Patrick's Day. But anyway. All right, so we need to hit a 7. Oh, but which is it, 7 or... Yeah, because it's a positive 2. So we're going to go with a positive 7 and a negative 5 for our intercept. So strategizing ahead of time. That should be a good margin there. All right, let's go ahead and get the full slope-intercept form here for the first inequality. Brandon.
Y is greater than or equal to 1/2 x plus 7.
There we go. We move the x over as a positive 1x, and when we divide everything by 2, we get y is greater than or equal to 1/2 x plus 7. So we've got our y-intercept of 7, which we already knew was coming. Abby thought it was a 14, but you know, just pause a moment, we're good. And then from there, class, we would need to rise 1, run 2, or fall 1, go backward 2. I had room to go up 1, so not that far. And solid or dashed? Solid. Come on, please let me shade the top. I would love to shade the top. I would be happy. All right. At least it's a short line. And then the next one, when we put this one into slope-intercept form, let's go to Michael.
Y is equal to...
Well, greater than or equal to?
Yeah. Negative 5/2 x minus 2. I don't know. Yeah. 5.
All right, so we already knew we were going to be at the negative 5. Now, here we're going to have to then class up 5, left 2. Solid or dashed? Solid, okay. They did this the last time, and it ended up being the big part. Surely they give us a little part here. Surely. All right, let's go back to our first inequality. Plug in the origin, 0, 0. Is it true or is it false, class?
What?
0 plus 0 is bigger than 14?
False.
Yay! False. I do not have to shade everything below my first line. I will shade tentatively everything above the first line. By the way, if you're wanting to go with single color, you could go lines sideways and lines vertical for the next shading. All right, then on the next one, we again plug in 0, 0. Is it true or false, class? It is true. So for my second line, I'm going to have to shade everything on this right-hand side. Now, normally, class, watch. Normally, I would shade all of this, correct? But really, I only need the part right here that satisfies this and this. So I just get this little bitty section here that's not bad at all. I did forget, by the way, on the last one, it asked for the vertex of intersection. Where is the vertex of intersection for this region? Negative 4, 5, right? Would be the vertex of intersection. It's, again, just picking up the point off the graph. How many had your vertex at negative 4, 5 and had that shaded region there? All right, questions on this one? All right, let's do one with 3. Number 7. The good news about 3 is it should give us a smaller region to have to eventually shade. Let's do a triple inequality. Numero 7. Stay. All right, we've got, let's take a 3 out of the first one, class.
3 x positive y is
Yeah, I don't like doing this. And then we got y is greater than 5. And let's take a negative 3 out of the last one.
x is greater than negative 5.
Good, when you divide the negative 3, remember, flip it around, so x is greater than negative 5. And there's all 3 inequalities. All right, let's do the last 2 first. Show me, or on your Cartesian plane, pick out where y would be 5. You see it? Where y is 5. It's right here, correct? In fact, technically, class, y is 5 at all of these points, isn't it? So what should I put right here? A dashed line. Where, though, would y be greater than 5, class? This is where y is 5. Where is y greater than 5? Above it. So everything above is my first shading. Again, don't shade too much, just enough that we see that's where the first set of shading is. Look at the next inequality. X is greater than negative 5. Well, find where x is negative 5. Hopefully, you came right here, didn't you? This is where x is negative, but technically, all these points, x is negative 5. So class, I should put a dashed line there. That's at 4. I had it and then I lost it. All right. Remove the evidence. Okay. So here x is negative 5. But where is x greater than negative 5? Everything on the right. So here, make that blend in, is my next set of shading. So far, class, only this region satisfies both, correct? But I'm going to narrow it down even more with a third inequality. 3x plus y is less than 2. What should I do about this one now, Maddie? I think she said plus 2. I just didn't hear it. All right, so we're going to put our y-intercept, of course, at 2. We'll rise 3, go backward 1. And connect at the dots, class, with a dashed line. All right, and how do I know which side to shade? The others, it was just if it's greater than 5, it's above 5. If it's greater than negative 5, it's to the right of negative 5. Here, how do I tell which side of this slanted line to shade? Which point? 0, 0 is not actually on that dashed line. Zoom in just a little bit more. So I can use 0, 0. Does 0, 0 work? Yes. So that means everything to this side is going to work, right, class? But remember, watching up here for a moment, it has to be to this side of that line while still being above that line and to this side of that line. In other words, you're going to get this little section here, bounded by negative 5, 5. Right here looks like a 1, 5, negative 1, 5. And then my graph grid doesn't really go high enough, but somewhere up here, they're going to intersect and finish off a triangle. Does anyone's graph grid extend high enough you can find that point of intersection? Anyone's graph grid high enough for that? Then let me cheat and look in the textbook, and it'll, never mind, the solution key isn't in the book. It's in a separate book that I don't have with me. If I had to guess, let's see. This is 5, this is 10. Looks like about 15-ish. So negative, I know it's going to be negative 5 something, right? Negative 5, 15 is my guess. Let's try plugging that in. Would a negative 5, no.
I think it's
Negative 5, 17 would give me a 2, wouldn't it? So it must be negative 5, 17 is where the last one would intersect. Make sense? All right, so we get that little triangle. Again, the boundary of the triangle, though, doesn't satisfy. None of the points in the boundary do. They're all dotted lines, but the points within the triangle would satisfy. Let's see, we got time for one more. Let's do one with a quadratic. Let's do number 20. Let's do number 20. Yes. All right. Going to the second inequality first while I'm getting my graph grid set up for number 20. The second one requires no math. How would I graph y is less than 6? Anybody?
Dash line and then 6.
Horizontal or vertical?
Horizontal.
Horizontal line through the 6 y value as a dashed line, and then shade everything
Below.
under it. Everything below it. So all of that. How many had that? Questions on that? For the next one, what shape? I mentioned already, for a parabola, 2 shifts.
Down 3.
Down 3, right, oh man, I should have given myself more room. Okay, so we're going to go to the right 5, down 3. The parabola goes up or down? It's going to go up. So we're going to go over and up, over and up. I've got room to go over up to 5 as well. It actually goes right to the line. And solid or dashed parabola? Dashed. All right. Test point. 0, 0. And when I plug in a 0, 0, what does the statement say when I plug into 0, 0? 0 is greater than 25 minus 3, or 22. Is that true? Is 0 bigger than 22? So instead of shading, class, watch, everything outside but still below this line, I shade everything inside but still below the line. And so we get just that figure there. Questions on number 20? Any questions at all on graphing systems of inequalities? You're sure you don't want to do this tomorrow instead of a field trip to the zoo?
No.
You could still change your mind. We could refund.
Wednesday.
Oh, that's right. We do. Okay, we do get to do this tomorrow. Okay, that's right. My brain keeps thinking Thursday's tomorrow. I'm one day ahead on everything. I'm just ready for spring break, apparently. I was doing this at the lunch table multiple times in conversations. My brain's ready for field trip for you guys to be. I'm just kidding. Anyway, homework for this evening is to do page 256. Yes, we will look at this tomorrow in our next lesson. Gavin does not have to suffer. On page 256, numbers 2, 8, and 10. Page 256, numbers 2, 8, and 10. Also want you to read pages 270 to 274. Also read pages 270 to 274. We're going to begin a new chapter tomorrow. We're going to kind of wrap this up and then begin a new chapter on matrices. It's not as scary as it looks, Maddie. She keeps eyeing that poster like it's, the most horrifying thing in the world. Reading over pages 270 to 274 so that you realize that matrices are not as scary as Maddie wants to make them seem. And we'll take a look at that tomorrow. So again, 2, 8, and 10 on 256. Have a great rest of your day. You are dismissed.